All right, let's go. Number 10. The bezoar stone. In 1575, Ambroise Paré, surgeon to the French crown, watched a condemned man die in agony over the course of 7 hours. The man had been given the royal antidote, a bezoar stone, ground to paste and dissolved in wine, administered to counter a measured dose of corrosive sublimate. The condemned had agreed to the procedure voluntarily. He had considered it preferable to execution. He was wrong. The bezoar did nothing. The mercury chloride did everything it was designed to do. What made Paré's account consequential was not that the antidote had failed. Failures were common in 16th century medicine. It was that European physicians had been prescribing bezoar stones as the definitive antidote to all known poisons for at least 600 years before that morning. No one had tested the premise. No one had thought to ask whether the premise held. These were supposed to be cures. Some of them were worse than the poison. The bezoar stone takes its name from the Persian bezoar, meaning antidote. The substance was first described systematically by the 10th century physician Muhammad ibn Zakaria al-Razi, known in the West as Rhazes, writing in Baghdad from a Sasanian medical tradition already centuries old. The logic was coherent within the medical framework of the time. An animal that grazed in the presence of toxic plants would inevitably ingest small quantities of poison over its lifetime. Those compounds would concentrate in the gastrointestinal system and form a calcified residue, a physical repository of everything harmful the animal had metabolized. That residue, administered to a poisoned human, would attract and absorb the same compounds. The stones formed when a foreign body, a swallowed hair, a fragment of plant material, became the nucleus around which calcium phosphate, magnesium ammonium phosphate, and calcium carbonate precipitated in concentric layers over years. Most commonly harvested from the intestinal tract of the Persian mountain goat, Capra agagrus, and later from the Andean llama, the bezoar had a distinctive layered structure when cut and polished, like a mineral cross-section of the animal's chemistry. By 1600, a single authenticated bezoar stone was selling in London apothecaries for more than its equivalent weight in gold. Queen Elizabeth I kept one set in a ring of gold and garnet, carried always. Philip II of Spain sent cases of them to his court physicians in 1562 with written instructions for their use. The great apothecaries of Venice, Florence, and Paris stocked them as their most valuable pharmaceutical item. A physician without access to bezoar stones was considered inadequately equipped. Here's where the complete dismissal of the mechanism begins to crack. Modern chemical analysis has confirmed that calcium phosphate, the primary structural component of a bezoar stone, shows no meaningful binding capacity for mercury chloride, arsenic trioxide, or antimony, the three most common poisons in active circulation in Renaissance Europe. For those specific compounds, the bezoar was inert. Paré's result was chemically inevitable. But for certain poisons in acidic solution, alkaline calcium compounds do exhibit real binding properties. Calcium phosphate has limited but genuine capacity to precipitate arsenic from an acid solution. The mechanism Rhazes proposed was not wrong in principle. The material was wrong. The principle, an alkaline adsorptive substance administered internally to bind dissociated toxins before they cross into the bloodstream, was correct. Consider where that principle ended up. Activated charcoal is the current FDA-recommended first-line intervention for acute oral poisoning in emergency medicine. It works by adsorption. Its porous surface area, approximately 300 square meters per gram, physically binds toxic compounds in the gastrointestinal tract before systemic absorption occurs. The standard dosing is 1 gram per kilogram of body weight, administered within the first hour of ingestion. At the right moment, with the right poison, it genuinely interrupts a poisoning. The principle Rhazes described in 10th century Baghdad, an adsorptive material administered internally to bind dissociated toxins before they act. The bezoar stone was the wrong form of that principle applied with the wrong material. Emergency rooms administer activated charcoal today. The condemned man in 1575 was given calcium phosphate. Same idea, 600 years apart. Physicians continued prescribing bezoar stones in European pharmacopoeias for another 200 years after Paré published his account of the failure in 1575. 2 centuries of prescription after the controlled test had already shown it did not work. The institutional weight of the remedy was stronger than the evidence against it. The mechanism survived the material's failure. It always does. Number 9. Terra sigillata. On one specific day each year, the sixth day of the ancient Greek month of Thargelion, falling roughly in late May, a ceremony took place on the island of Lemnos in the northern Aegean. Priestesses would walk to a hillside outside the town of Hephaestia, cut portions of a distinctive red clay from a surface exposure that appeared once per year, mix the clay with goat's blood, shape it into small flat tablets, and stamp each one with the official seal of the island, sealed earth, terra sigillata. Galen of Pergamon, the most prolific medical writer of the ancient world and court physician to Marcus Aurelius, traveled personally to Lemnos in 166 CE to witness this process. He was not a credulous man. He had already written systematic critiques of physicians who prescribed remedies without clinical observation. He stayed on Lemnos long enough to acquire a full year's production, document the process in detail, and conduct his own informal trials. It was, he concluded, effective against hemorrhage, dysentery, bites from venomous animals, and acute poisoning. He distributed his supply to physicians across the Roman Empire and wrote explicit instructions for its use. The clay's provenance was specific. Galen noted that the Lemnian hillside produced only a limited quantity each year, that the extraction had to occur during the annual ceremony, and that clay taken from adjacent locations on the same island at other times of year did not produce the same results. He did not know why. He recorded that it was so. The island continued producing the clay under Byzantine and then Ottoman administration. By the 16th century, the Sultan's court maintained a formal supply. A Spanish physician named Xavier de Soto documented seeing Lemnian earth administered in Istanbul in 1551 in identical tablet form, under a ceremony essentially unchanged from what Galen had described 14 centuries earlier. The Ottoman Sultan's physicians were prescribing a product formulated under Roman quality control protocols. The tablets were still stamped with the official mark. The preparation had outlasted Rome, Byzantium, the Crusades, and the fall of Constantinople. The clay's composition: aluminum silicate, iron oxide, which gives it the distinctive red coloration, with trace calcium and magnesium. Not unusual mineralogy. What distinguished the Lemnian deposit was the specific ratio of silicate fractions and the fineness of the particle structure, both of which depended on the precise geological formation of that hillside. Aluminum silicate in the kaolin family is a genuine gastrointestinal adsorbent. In the human gut, fine particle aluminum silicate physically binds gram-negative bacterial enterotoxins, interrupting the signaling cascade that drives secretory diarrhea. The greater the surface area and the finer the particle structure, the more effective the adsorption. The ritual was the regulatory system. Kaolin was the active ingredient in kaopectate from its introduction in the United States in 1937 until 2003, when the FDA approved the substitution of bismuth subsalicylate. For 66 years, the over-the-counter anti-diarrheal that Americans trusted was aluminum silicate clay. Galen had documented its clinical efficacy in 166 CE. Bismuth subsalicylate is the compound in Pepto-Bismol. It operates by a related mechanism, a heavy metal compound binding to endotoxins in the GI tract. The bismuth component performs the same adsorptive function. The salicylate component provides additional anti-inflammatory action in the intestinal lining. Galen would have recognized neither compound by name. He would have recognized the outcome. The official stamp on each Lemnian tablet was not ceremonial. It was authentication of a specific geographic deposit with a specific mineral composition. Different clay from a different hillside would not have worked as well. The provenance ritual was, in effect, a supply chain integrity protocol enforced through religious ceremony because no other enforcement mechanism existed. The priests were guaranteeing pharmaceutical specifications that no one in 166 CE could have named. The tablet shapes changed. The aluminum silicate did not. Number 8. Snake oil. The insult is so complete it has obscured the fact. Snake oil entered the English language as a synonym for fraud in the 1860s, and by the time the Food and Drug Administration formalized its definition of therapeutic fraud in the early 20th century, the phrase had fully detached from its origin. The origin was real. Chinese laborers brought to build the Central Pacific Railroad through California's Sierra Nevada in the 1860s carried with them a traditional remedy: oil rendered from the Chinese water snake, Anhydrus chinensis, a semi-aquatic species native to the rivers and paddies of southeastern China. At the end of each shift, after working with iron and stone and black powder at altitude and temperatures that swung 40 degrees between day and night, they would rub the oil into their joints. American supervisors watching this recorded it as superstition. Patent medicine salesman took the name. In 1989, biochemist Richard Koonin at the University of California, San Francisco, obtained authentic Chinese water snake oil through traditional medicine suppliers and conducted a full fatty acid analysis. The eicosapentaenoic acid content EPA, the omega-3 fatty acid most directly associated with anti-inflammatory activity in the research literature, was 20.1% of total fatty acid content. Atlantic salmon, considered among the richest conventional dietary sources of EPA, contains 17.6%. Eicosapentaenoic acid converts in the body to prostaglandin E3. Prostaglandin E3 competes with and suppresses the prostaglandin E2 cascade, the same biochemical pathway that drives joint inflammation, swelling, and pain. This is not a traditional medical theory. It is the mechanism of action published in peer-reviewed pharmacology. The railroad workers applying Chinese water snake oil to their joints were delivering 20% EPA topically, directly over the inflamed tissue. The fraud began separately. Clark Stanley's snake oil liniment, sold by a traveling showman known as the Rattlesnake King, across the American Midwest from 1893, was marketed with theatrical demonstrations involving live rattlesnakes. When federal agents analyzed it in 1917 under the Pure Food and Drug Act of 1906, the product contained mineral oil and beef fat, no snake-derived compound, no fatty acids of any kind beyond the beef tallow, 0. Stanley paid a fine of $20. The fraud took the name. The original disappeared from Western pharmacology for nearly a century. The prescription medication Vascepa, eicosapentaenoic acid in pharmaceutical-grade purified form, received FDA approval in December 2019, following the Reduce-It trial, published in the New England Journal of Medicine in November 2018. In that trial, involving 8,179 high-risk cardiovascular patients at 473 sites across 11 countries, Vascepa at 4 grams per day reduced major adverse cardiovascular events, including non-fatal myocardial infarction, non-fatal stroke, and cardiovascular death, by 25% compared to placebo. It is currently prescribed by cardiologists to prevent heart attacks. The active compound is eicosapentaenoic acid, the same compound Koonin measured in water snake oil in 1989. The same compound a railroad supervisor dismissed as Chinese superstition in the Sierra Nevada in 1862. They were right. No one asked why. The fish oil supplement market in the United States reached $3.4 billion in annual sales by 2022. The active compound in most of those capsules is EPA, often from fish species with lower concentrations than the Chinese water snake. The name became a slur. The chemistry survived. Number 7. Unicorn horn. The Officina Profumo Farmaceutica de Santa Maria Novella in Florence has been operating since 1221. It is the oldest pharmacy in the Western world, still selling products today. Its 16th century inventory included, among its most valuable items, a narwhal tusk measuring approximately 7 feet in length, appraised at a value comparable to a small rural estate. It was not displayed as a curiosity, it was dispensing inventory. Powdered alicorn, meaning unicorn horn, which was always narwhal tusk, was prescribed across Renaissance Europe for poisoning, plague, fever, epilepsy, and as a general preventive against all disease. The narwhal, Monodon monoceros, is a toothed whale native to the Arctic waters around Greenland, Canada, and Russia. Its elongated left canine tooth, spiraling to a point over distances up to 10 feet, reached European markets through Greenlandic Norse traders who understood the value of maintaining the mystery around the source animal. Rudolph II, Holy Roman Emperor, paid 100,000 gold ducats for 2 authenticated tusks around 1600. That figure was comparable to the annual tax revenue of a substantial continental principality. By mid-century, a single large tusk in the London market sold for the equivalent of 10 times its weight in gold. Queen Elizabeth I received a tusk valued at £10,000 in 1577, a sum sufficient to purchase a castle in its lands. Apothecaries ground sections of the tusk to fine powder and dissolved it in wine or water for internal administration. They also carved the tusk into cups and sold them as poison detectors. A cup made from alicorn when filled with liquid containing poison was said to produce visible bubbling and to sweat on its exterior surface. The bubbling was real, the interpretation was wrong. Narwhal tusks are composed of hydroxylapatite, a calcium phosphate mineral in a specific crystalline structure with an outer layer of dentine. Hydroxylapatite is strongly alkaline, with a pH in solution approaching 9. When an alkaline material contacts an acidic liquid, carbon dioxide is released. The bubbles that physicians and courtiers interpreted as proof of poison detection were a reaction to acidity. Any acid would produce the same result: vinegar, citrus juice, wine in early souring stages, the weak acids in normal fermentation. None of it indicated arsenic, antimony, or aconite. But here's where complete dismissal of the material fails. Hydroxylapatite in alkaline environments exhibits genuine binding capacity for certain heavy metals. Lead and arsenic, both common constituents of the poisons actively in circulation in Renaissance courts, bind to hydroxylapatite surfaces through ion exchange reactions. The mechanism the physicians proposed, that the horn attracted and neutralized poisons, was wrong in its theory. The material for two specific and common poisons was not wrong in its effect. The horn was inert for most things. The compound was not inert for everything. Modern orthopedic and dental surgery uses synthetic hydroxylapatite as the primary bone graft substitute. The compound is osteoconductive, meaning it supports new bone tissue growth along its surface through a process in which osteoblasts use the hydroxylapatite matrix as a scaffold, gradually replacing it with native bone as the graft integrates. The FDA first approved hydroxylapatite bone graft substitutes in the early 1990s. It is now standard material in spinal fusion surgery, dental socket preservation after tooth extraction, and craniofacial reconstruction following trauma or cancer resection. The white ceramic powder packed into a fractured bone site today is chemically identical to what a 16th century Florentine apothecary ground between two flat stones. Different story, same molecule. Number 6. Mithridatium. Sometime around 80 BCE in the palace complex at Sinope on the southern shore of the Black Sea, in modern-day Turkey, the king of Pontus established a daily protocol that would be prescribed by physicians for the next 1,700 years. Each morning, Mithridates VI consumed a measured preparation of small doses of known poisons: arsenic, aconite, the flesh of venomous animals, select plant alkaloids including belladonna and henbane. The formulation was developed by his court physician, Cratuus, the first systematic botanical pharmacologist by any historical accounting. Cratuus produced an illustrated herbal, the earliest known, and documented the active compounds of hundreds of medicinal plants. He was not producing folk remedies. He was conducting applied pharmacological research. Mithridates was not consuming the preparation out of compulsion. He was testing a hypothesis that regular sublethal exposure to poisons would produce immunity. He was also testing it experimentally. He had condemned prisoners poisoned and then administered the preparation. He recorded the outcomes. The preparation was refined accordingly. The king was the trial. The patients were willing. When Pompey defeated him in 63 BCE and Mithridates attempted to use poison to kill himself rather than face capture, the poison did not work. He had to ask a soldier to stab him. This was documented by Cassius Dio and referenced by multiple Roman historians. The story was considered remarkable not because it was doubted, but because the immunity was treated as real. The recipe Pompey found in the palace was translated into Latin by his physician Linnaeus. It entered Roman pharmacology immediately. Galen's formulation ran to 61 ingredients. Renaissance versions reached 65. Every European pharmacy through the early 19th century stocked some version of what became known as mithridate or mithridatium. It was prescribed for poisoning, plague, fevers, bites from venomous animals, and as a general antidote to all corruption. The modern immunological literature would not have recognized what Mithridates was doing as immunotherapy. The field did not exist. The immune system had not been named as a system. Adaptive immunity, the process by which repeated antigen exposure produces B and T cell responses calibrated to that specific antigen, would not be described until the 20th century. But the mechanism was precise. Repeated sublethal exposure to an antigen, escalating gradually, producing a progressive tolerance response. The modern description of allergen immunotherapy. Dr. Leonard Noon at St. Mary's Hospital, London, published the first systematic clinical paper on allergen desensitization therapy in 1911, 4 years before the word allergy entered clinical vocabulary. His subjects received escalating subcutaneous doses of pollen extract over several weeks, until their immune systems stopped overreacting to seasonal exposure. The therapeutic logic was the same logic Mithridates had applied to arsenic and aconite 20 centuries earlier. The FDA approved Palforzia in January 2020, an oral immunotherapy for peanut allergy consisting of ground peanut protein, administered in escalating daily doses on a supervised clinical schedule. In the Phase 3 Palisade trial, 67.2% of treated children reached the primary tolerability endpoint against 4.0% of the placebo group. The treatment is now available in pediatric allergy clinics across the United States. 2,000 years between the formulation and the mechanism that explains it. One continuous idea. Number 5. Mercury. Paracelsus arrived in Basel in 1527 with a reputation for cures no one else could produce, and a philosophy that would define the next 4 centuries of pharmaceutical toxicology. The dose makes the poison. He meant it precisely, not rhetorically. Any compound in sufficient quantity is a poison. Any poison in the right quantity is a medicine. The boundary between therapeutic and lethal is a number, not a category. His primary application of this principle was mercury. Syphilis had spread across Europe at scale from 1494 following the Italian war campaigns, moving through the continent with a speed that led most contemporary physicians to record it as something new. By 1530, it was killing people within months of primary infection in its most virulent early century form. The available treatments, guaiacum wood infusions, and sweat baths, were producing no measurable outcomes. Paracelsus prescribed mercury. The protocol, approximately 3 grams of mercuric ointment per day, rubbed into the armpits, groin, and inner thighs, where the skin is thin and absorption through the lymphatic system is most efficient. Duration: 6 to 8 weeks for a full course. Expected and required effects: the patient's skin would peel. Their gums would blacken and recede from the teeth. The teeth would loosen in their sockets. They would produce 2 to 4 liters of saliva daily, continuous and uncontrollable throughout the course of treatment. Physicians called this salivation therapy and considered the extreme drooling proof that the mercury was expelling the syphilitic corruption through the salivary glands. The theory was wrong. The outcome for a substantial portion of patients was recovery. Mercury is bactericidal against Treponema pallidum, the spirochete responsible for syphilis, at concentrations achievable in human tissue through the skin absorption protocol Paracelsus described. In vitro studies have confirmed growth inhibition of T. pallidum at mercuric chloride concentrations of 0.1 milligrams per liter. The spirochete is unusually sensitive to heavy metal toxicity compared to many other bacteria. Patients who completed a full course of mercury treatment and survived often did recover from primary and secondary syphilis. The mercury had found its biological target while destroying adjacent tissue in the gums, kidneys, and nervous system simultaneously. The toxicology and the pharmacology were the same action. The mortality rate from mercury toxicity among treated patients has been estimated at between 10 and 20% by multiple historical medical reviews, including analyses conducted by the Wellcome Trust. The therapeutic window, the margin between the dose that killed T. pallidum and the dose that killed the patient, was measured in milligrams and varied with body weight, renal function, and the duration of ongoing exposure. Some physicians understood this distinction. Most administered by protocol, not by measurement. Mercury-based medicine continued as the primary syphilis treatment in every major European pharmacopoeia from Paracelsus in 1530 to Paul Ehrlich's synthesis of salvarsan in 1910. 380 years of continuous prescription. Thimerosal, with a molecular weight of 404.81 grams per mole and a mercury content of 49.6% by weight, is currently used as a preservative in multi-dose influenza vaccine vials and certain other multi-dose biologics. It prevents bacterial contamination of vials that will be opened and resealed multiple times over the course of a vaccination campaign. The CDC estimates approximately 180 million influenza vaccine doses were administered in the United States during the 2022 to 2023 season. A portion of those doses came from multi-dose vials containing thimerosal. Dental amalgam, a compound of approximately 50% liquid mercury combined with silver, tin, and copper alloy, remains in the teeth of an estimated 75 million Americans. The FDA issued revised guidance on dental amalgam in 2023, recommending against its use in pregnant women, children under 6, and people with neurological conditions, while stopping short of recommending removal of existing restorations in otherwise healthy adults. The compound a Paracelsian physician rubbed into a soldier's armpits in 1540, still present in sealed vials in your pharmacist's refrigerator, still present in the mouths of 75 million people who do not think of it as ancient medicine. Not the same application, the same element. Number 4. Theriac. Andromachus the Elder, personal physician to Nero, received the mithridate formula around 54 CE and concluded it was insufficient. His revision: retain the core structure, double the opium content, and add one component that no previous formula had included: the flesh of a dried and powdered viper, specifically Vipera aspis, the asp, which Andromachus believed would counteract all venomous poisons through a principle of like against like. The result was theriac. It would be prescribed continuously for the next 1,700 years. Galen of Pergamon, writing in the 2nd century CE, considered theriac the most important of all medicines. He administered it to Marcus Aurelius. He kept stocks that had been aging for 12 years and would not dispense any preparation younger than that, arguing that the chemical interactions between the 64 ingredients required extended time to reach their full effect. He was enforcing an aging requirement that suggested, without his having the framework to explain it, that theriac's pharmacological properties changed during aging in ways that mattered. The Renaissance formula ran to 64 ingredients. An analysis of the core pharmacologically active components shows opium, providing direct analgesia and sedation; beaver castoreum, which contains salicylic acid, the active precursor to aspirin, providing anti-inflammatory and fever-reducing action; cinnamon, with documented antimicrobial properties in vitro; and honey, also antimicrobial and effective as a wound treatment in its own right. The remaining 60 ingredients were primarily botanical fillers with varying levels of pharmacological activity. Venice assumed production control in the 12th century and created a formal pharmaceutical manufacturing system around theriac that had no precedent in the ancient world. The city's doge and senior magistrates were legally required to witness annual production personally. Competing apothecaries' guilds bid for the manufacturing contract. Venetian theriac had to be aged a minimum of 12 years before it could be dispensed. The formula was standardized, the process was witnessed, the product was authenticated with the seal of the Republic. Venice exported it to courts and hospitals across Europe and the Ottoman world. They were building pharmaceuticals. They did not have the word. This was not folk medicine. It was industrial pharmaceutical manufacturing, with state oversight, mandatory quality aging, and documented formulation standards. In 1,700 years of continuous prescribing, no systematic comparison was ever conducted between patients who received theriac and patients who received nothing. No one requested one. The institutional weight of 17 centuries of production was considered sufficient evidence. Now consider the pharmacological architecture embedded in the formula. Percocet is oxycodone combined with acetaminophen. Vicodin is hydrocodone combined with acetaminophen. The clinical rationale: the opioid provides direct central nervous system analgesia, while the non-opioid analgesic handles peripheral inflammation, allowing lower doses of each compound to achieve equivalent pain relief with reduced side effect burden. The combination outperforms either compound alone at equivalent doses. Theriac was an opioid combined with a salicylate, an antimicrobial, and additional supportive botanicals, manufactured under quality-controlled conditions to a standardized formula verified by state witnesses. The logic is not different. The dose calibration is different. The mechanistic understanding is different. The architecture of combining an opioid with a synergistic anti-inflammatory in a regulated pharmaceutical formulation is the same architecture. The theory evolved. The structure stayed. Number 3. Foxglove. In 1775, Dr. William Withering, a physician in Birmingham, received a case he could not resolve. A patient with severe dropsy, the accumulation of fluid in the extremities and chest that indicated failing cardiac function, had not responded to any available treatment. A colleague mentioned that a woman in rural Shropshire had developed a local reputation for curing the condition with an herbal preparation. Withering traveled to see her. The preparation contained more than 20 plant species. He spent several visits working through the formula systematically, eliminating species one by one through clinical observation, until he had isolated the plant producing the therapeutic effect. Digitalis purpurea, the purple foxglove. It grew in any English hedgerow. It had been in the English landscape since before recorded medicine. No physician had thought to formalize what the herbalist in Shropshire already knew. Withering spent the next 10 years documenting 163 patients in clinical detail, presenting condition, the precise dose administered, the physiological response at each dose increment, adverse effects observed, and final outcome. He mapped the dose-response relationship before that term existed in clinical pharmacology. He identified the toxic threshold in the patient populations most likely to benefit and most likely to be harmed. He described the cardinal sign of overdose, a characteristic disturbance of vision producing halos around light sources, which remains a clinical warning sign for digoxin toxicity today. His monograph, An Account of the Foxglove, published in 1785, is the first systematic clinical pharmacological case series in the English language. It established the template for how botanical medicines should be documented and evaluated: individual patient records, dose tracking, adverse effect reporting, outcome measurement. It predated by a century the institutional frameworks that would make this methodology standard. The chemistry was characterized over the following 140 years. Two primary cardiac glycosides, digoxin and digitoxin. The mechanism is precise and was not understood until the 20th century. Digoxin inhibits the sodium-potassium ATPase pump in cardiac muscle cells. This inhibition raises intracellular sodium, which in turn reduces calcium efflux from the cell, increasing calcium availability for muscle contraction. The result is two simultaneous therapeutic effects: slowed atrioventricular conduction rate, which controls atrial fibrillation, and increased contractile force per beat, which addresses heart failure. Two clinically distinct indications from one mechanism. The therapeutic window is narrow. The lethal dose is approximately twice the effective therapeutic dose, measured in micrograms per kilogram of body weight. A physician who uses digoxin today calibrates dose to serum drug levels, renal function, and body composition. Withering calibrated by watching the patient's pulse and stopping when the heart rate dropped to his target. It is still working. We are still learning why. 3.8 million digoxin prescriptions were filled in the United States in 2019, according to the IQVIA National Prescription Audit. The ACC and AHA 2019 atrial fibrillation guidelines include digoxin as a recommended adjunct rate-controlled agent for patients who fail or cannot tolerate first-line therapy. It has been in every major cardiac formulary for 230 continuous years. In 2020, a paper in Nature Communications identified digitoxin as exhibiting broad-spectrum antiviral activity against respiratory syncytial virus and influenza A in preclinical models through a mechanism involving inhibition of viral RNA translation. The same leaf compounds a Shropshire herbalist was brewing in the 1770s are entering antiviral research in the 2020s. The Digitalis Investigation Group trial in 1997 produced data suggesting possible harm in women with heart failure, causing a sharp decline in prescribing through the late 1990s and 2000s. Later reanalysis challenged the methodology of the subgroup analysis. Prescribing stabilized. The patient receiving digoxin today, one of 3.8 million in 2019, is taking a compound that a woman in rural Shropshire was brewing from roadside plants before the United States existed as a nation. Nothing was discovered, something was noticed. Number 2. Willow bark. The Ebers Papyrus is 110 pages of medical text recovered in 1874 by Egyptologist Georg Ebers from a tomb in Thebes and now held at the University of Leipzig. It was copied approximately 1550 BCE and represents medical knowledge that predates the copy. Among its 877 prescriptions is a preparation of willow bark for fever and joint pain, with specific instructions: a measured portion in warm water, administered twice daily. The Egyptians had not invented this, they had written it down. Hippocrates, circa 400 BCE, described willow bark tea for fever reduction and for pain during labor. Dioscorides documented it in Materia Medica in the 1st century CE. The Assyrian clay tablets of the Neo-Assyrian Empire, the Chinese pharmacopoeia attributed to Shen Nung in the 1st century CE, and the medical traditions of indigenous peoples of eastern North America all document willow bark as a treatment for fever and pain. This is convergent discovery at civilizational scale. Cultures with no documented contact across a span of at least 3,000 years arriving independently at the same plant for the same clinical applications. That is not coincidence. That is the same pharmacology being discovered repeatedly by people paying close attention to what the world in front of them was doing. Reverend Edward Stone of Chipping Norton, Oxfordshire, wrote a letter to the Royal Society in April 1763 reporting 5 years of systematic clinical observations in 50 patients treated with dried willow bark powder for intermittent fever. His dosing was precise: 1 dram in water every 4 hours during an acute fever. His records tracked dosing, duration of treatment, outcome, and adverse effects. He was doing what Withering would do with foxglove 12 years later, in the same country, with the same methodological instinct. Felix Hoffmann at Bayer Laboratories synthesized acetyl-salicylic acid in stable crystalline form on August 10, 1897. The active compound in willow bark, salicin, is metabolized in the human body to salicylic acid, which produces the analgesic and anti-inflammatory effect. Salicylic acid at therapeutic doses is harsh on gastric mucosa, causing irritation and bleeding with regular use. Hoffmann's acetylated version reduced gastric irritation significantly while preserving the therapeutic activity. This was a genuine pharmacological improvement over the natural compound. But the metabolic conversion Hoffmann's chemistry pre-solved was already happening, automatically, in the liver of every Egyptian fever patient who drank willow bark tea in 1550 BCE. The body converted salicin to salicylic acid without anyone knowing about it. The drug was working for 3,000 years before anyone understood the mechanism. Approximately 100 billion aspirin tablets are consumed globally per year, according to the Aspirin Foundation. An estimated 40 to 50 million Americans take daily low-dose aspirin at 81 milligrams for cardiovascular event prevention. At this dose, aspirin irreversibly inhibits cyclooxygenase 1 in platelets, preventing thromboxane A2 synthesis and reducing platelet aggregation for the lifetime of the platelet, 7 to 10 days. The platelet cannot regenerate cyclooxygenase. The inhibition is complete until new platelets form. In 1918, Bayer had been producing and marketing aspirin for 20 years and was the dominant global pharmaceutical company. When the influenza pandemic struck, physicians prescribed aspirin for influenza fever at doses ranging from 8 to 31 grams per day. The current maximum recommended adult dose is 4 grams per day for acute pain. At doses above 8 grams daily, aspirin causes respiratory alkalosis, followed by metabolic acidosis, and pulmonary edema through a mechanism entirely distinct from its antipyretic effect. A 2009 paper by Karen Starko published in the Annals of Internal Medicine proposed that a substantial fraction of the second wave 1918 pandemic deaths, concentrated in the catastrophic fall wave, may have been aspirin toxicity misattributed to the influenza pneumonia. The death records from 1918 are not granular enough to distinguish viral pneumonia from aspirin-induced pulmonary edema at autopsy. The plant was blameless. The dose was not. 2,400 years, same molecule, still inside you. Number 1. The opium poppy. The first written record appears on Sumerian cuneiform tablets, recovered by the University of Pennsylvania's excavations at Nippur, and dated to approximately 3,400 BCE. The poppy is called hul-gil, the plant of joy. The cultivation instructions specify: sow in the evening, harvest the seed capsule in the morning light, score the green surface of the mature capsule with a blade and let it bleed. The white latex that bleeds from a scored capsule dries to a brown resin overnight. It contains morphine at concentrations between 4 and 21% by dry weight, depending on the cultivar and growing conditions, along with codeine, thebaine, noscapine, and papaverine. When these alkaloids enter the human body, they bind to the mu-opioid receptors in the central and peripheral nervous system, with an affinity that pharmacologists still use as the reference standard for opioid receptor characterization. Those receptors exist because the human brain produces its own opioid compounds: beta-endorphin, met-enkephalin, leu-enkephalin. These endogenous opioids regulate pain, stress response, reward, and breathing. The poppy alkaloids are not tricking a system foreign to the body. They are entering a system the body built for itself and activating it at orders of magnitude beyond its normal operating range. That is the fact that makes everything after it coherent and everything after it catastrophic. The Egyptian Eber's Papyrus, 1550 BCE, opium preparations for acute pain and infant sleep. Greek physician Diagoras of Melos, circa 400 BCE, documenting both therapeutic and fatal doses. Alexander the Great's military physicians administering it to the wounded at the Hydaspes campaign in 326 BCE. Avicenna's Canon of Medicine, 1025 CE, the most comprehensive standardized dosing protocol for opium, written before the 19th century, including the warning that habitual use produced dependency from which recovery was difficult. Friedrich Serturner, a pharmacist assistant in Paderborn, Germany, isolates morphine from opium resin in 1804 and names it after Morpheus, the Greek god of dreams. He is 21 years old and working without institutional support. He consumes the purified compound himself to test its properties and documents a near-fatal overdose. The isolation of morphine is the founding event of alkaloid chemistry, the discipline that produces codeine, quinine, strychnine, atropine, cocaine, and nearly every other plant-derived pharmaceutical developed in the following century. Alexander Wood, a physician in Edinburgh, invents the hypodermic syringe in 1853 and uses morphine as his primary test compound. Intravenous delivery bypasses first-pass metabolism in the liver and gastric absorption delays. Bioavailability rises from approximately 30% by oral route to effectively 100% intravenous. The dose required to produce the same effect drops by 2/3. The window between the therapeutic dose and the dose that suppresses the respiratory drive to the point of death narrows proportionally. Heinrich Dresser at Bayer Laboratories synthesizes diacetyl morphine in 1898. The molecule crosses the blood-brain barrier approximately twice as fast as morphine, producing a more rapid onset and a correspondingly more intense reinforcement signal. Bayer's clinical team tests it internally. They report that users feel heroic. Bayer names the compound heroin, from the German heroisch, and markets it explicitly as a non-addictive substitute for morphine and as a cough suppressant for children. The non-addiction claim was not supported by the cited clinical evidence. The marketing ran for 15 years before international pressure, and accumulating overdose data forced restrictions beginning in 1913. Martin Freund at the University of Frankfurt synthesizes oxycodone from thebaine, a minor alkaloid in the same poppy, in 1916. It enters clinical use in Germany in 1917. It does not arrive in the American pharmaceutical market with significant commercial force until 1996, when Purdue Pharma launches OxyContin, with the marketing claim that less than 1% of patients using long-acting opioids develop addiction. That claim was sourced from a 101-word letter to the New England Journal of Medicine published in 1980. Not a clinical trial, not a pharmacological study, a letter. Purdue Pharma declared bankruptcy in September 2020. United States opioid overdose deaths by year, as documented by the CDC National Center for Health Statistics. 8,048 in 1999, 21,088 in 2010, 42,249 in 2016, 80,816 in 2021. Fentanyl, synthesized by Paul Janssen in 1960, is 100 times more potent than morphine by weight. It occupies the opioid receptor at doses measured in micrograms. The first documented illicit fentanyl overdose deaths in the United States appeared in 1979 in a cluster in Southern California linked to a clandestine synthesis operation. Fentanyl is now the primary driver of opioid overdose mortality in the United States, present in the majority of overdose deaths regardless of the substance the user believed they were taking. The overdose mechanism has not changed since the first documented fatal dose of opium. The respiratory drive originates in the pre-Butzinger complex of the brainstem. Opioid receptor activation in that region suppresses the automatic respiratory rhythm. The rate of breathing slows, then it stops. Consciousness is not lost before the respiratory failure completes, or sometimes it is. The mechanism does not distinguish. The race for a non-addictive opioid has been underway since the 1970s, when the discovery of endogenous opioid receptors and enkephalins by teams, including those of Candace Pert and Solomon Snyder, opened the theoretical possibility of a compound that could activate analgesia without activating addiction pathways. Buprenorphine, introduced in the 1980s and now a standard medication-assisted treatment for opioid use disorder, is itself a partial opioid agonist that produces dependency and requires ongoing prescription management. Methadone, introduced as a heroin substitute in the 1960s, has its own overdose pharmacology and diversion problem. Tramadol, marketed as a less addictive alternative when it launched in the United States in 1995, is now a Schedule IV controlled substance. The plant is still winning. The Sumerian farmer who scored a poppy capsule in Nippur in 3400 BCE, watching the white latex bleed out in the first morning light, had found something the human nervous system could not say no to. We have not, in 5,400 years, found anything that changes that fact. The 80,816 Americans who died of opioid overdose in 2021 were each metabolizing a compound that is a direct chemical descendant of the resin on that Sumerian hillside. Unbroken lineage from the naming to the worst year in its recorded history, the plant of joy, still. These 10 items do not form a comfortable story. The pattern is not that ancient medicine was sophisticated. Some of it was mercury at levels that destroyed the nervous system. Some of it was antidotes that watched patients die while the poison finished its work. Some of it was ground narwhal tusk prescribed for the plague by physicians who charged more for that prescription than a laborer earned in a year. The pattern is more precise. In case after case across these 10 items, the active compound was operating correctly, independently of the theory attached to it. The physicians were wrong about why things worked. The chemistry was right or wrong on its own schedule, regardless of what was written in the case notes or the pharmacopoeia. Consider what the record shows. Willow bark metabolizing to salicylic acid in the liver of a fever patient in 1550 BCE, before anyone had named the liver's metabolic role. Foxglove inhibiting the sodium-potassium ATPase pump in the heart muscle of a dropsy patient in 1775, 60 years before that pump was identified as a structure. Mithridatium inducing adaptive immune tolerance in 80 BCE, 19 centuries before immunology existed as a named discipline. The active compounds were doing their work in bodies that had no theoretical framework for what was happening. The theory came later, or not at all. Some of these compounds are still in use today, still working, in clinical populations with sophisticated theoretical frameworks who have no idea that the word for what they are taking comes from a plant that was old before the Roman Empire. There are botanical pharmacopoeias currently in active practice across South America, Central Africa, and Southeast Asia that have not entered the systematic pharmacological literature. Plants being administered today in empirical traditions that stand in the same relationship to the published literature that willow bark stood to Hippocrates. Some of those compounds are working. The mechanism is unknown because the question has not been formally asked. The bezoar stone sits in a museum archive. Activated charcoal sits in an emergency room cabinet 12 blocks away. The pharmacological distance between them is smaller than the institutional distance suggests. The Lemnian red clay sits in a collection case. Pepto-Bismol sits in a pharmacy aisle. The narwhal tusk sits behind museum glass. Hydroxylapatite bone graft material is being packed into fractured bones in surgical suites this week across 100 hospitals. The mechanisms were real before anyone could name them. Some of them were real before anyone thought to check. Everything else is a footnote. If you want to see more videos like this, click the video on screen now and make sure to subscribe.